Imagine calling a number and asking the sky for rain. Minutes later, radar screens light up, clouds thicken, and the first drops hit a bone-dry desert. Sounds like science fiction. Today, we're diving into the real tech that nudges clouds to rain what works, what doesn't, and why the latest 2024 to 2025 research says we're still not weather gods. Can humans make it rain? The science, the hype, and the hard limits? Before we tinker, we need the recipe. Rain starts with water vapor rising, cooling and condensing onto tiny particles, dust, pollen, sea salt forming cloud droplets, or ice crystals. Most droplets are so small, they never fall. They evaporate inside the cloud. To become rain, droplets must grow by colliding and merging in warm clouds, or by freezing, growing, and falling as snow that melts on the way down in cold clouds. The key insight: if we can add the right kind of particles at the right time and place, we might tip the odds so more droplets grow big enough to fall. That's the core idea behind cloud seeding, a technique that's been around since the 1940s, but is seeing a renaissance with new tech and urgent water needs. Let's start with the classic method. Silver iodide, small planes, or ground-based generators release this compound into clouds. Why? Its crystal structure closely mimics ice, tricking water vapor into freezing around it. More ice nuclei mean more potential raindrops or snowflakes. But here's the catch. No clouds, no seeding. You can't conjure storms from thin air. Cloud seeding only works when nature provides the right conditions. Supercooled water droplets in clouds cold enough to support ice formation. Recent randomized trials in the western U.S. have given us the clearest picture yet of silver iodide's effectiveness. Scientists can now track seeded plumes as they transform into visible snowbands on radar. The effect size, small but significant, under specific conditions, potentially boosting snowpack by 5 to 15% in targeted mountain ranges. Now, let's jump to the cutting edge. In 2024, the United Arab Emirates made headlines with drone-based cloud seeding. These unmanned aerial vehicles can navigate precisely into promising cloud formations, releasing not just particles, but electrical charges. The idea: manipulate the cloud's internal electric field to encourage droplet growth and collision. Meanwhile, in labs across Europe and Asia, researchers are experimenting with lasers. High-powered pulses create plasma channels in the air, potentially serving as pathways for rain formation. It's early days, but the concept of laser-induced condensation is pushing the boundaries of what we thought possible in weather modification. But let's be clear, we're not weather gods yet. The World Meteorological Organization states unequivocally, there are no demonstrated methods to tame severe weather or tropical cyclones. Cloud seeding can't create rain from nothing, end droughts overnight, or steer hurricanes. So what can it do? In the right conditions, cloud seeding might increase precipitation by 5 to 20%. That may not sound like much, but for water-stressed regions, it could mean the difference between a failed crop and a successful harvest. Take China, for instance. The country operates the world's largest weather modification program, covering an area 3 times the size of Spain. They claim to have increased rainfall by up to 10% in some regions, potentially adding billions of cubic meters to their water resources annually. Australia, too, has been a pioneer. The Snowy Mountains Cloud Seeding Program has been running since 2004, aiming to boost snowfall and, ultimately, water inflow to critical reservoirs. Long-term data suggests a 14% increase in precipitation over seeded areas. But cloud seeding isn't just about more water, it's about when and where that water falls. Ski resorts use it to guarantee fresh powder. Farmers might seed to protect crops from hail damage, and some cities have explored seeding to reduce air pollution by encouraging rain to wash away particulates. As promising as these applications sound, we can't ignore the ethical debates. Who owns the rain? If one region seeds clouds, are they stealing water from downwind neighbors? What about unintended consequences on ecosystems or weather patterns? These questions become even more pressing as climate change alters precipitation patterns worldwide. Some see cloud seeding as a potential adaptation tool. Others worry it's a band-aid solution, distracting us from necessary emissions reductions. Environmental concerns also come into play. While silver iodide concentrations from seeding fall well below toxicity thresholds, long-term accumulation in sensitive alpine ecosystems is still being studied. The good news, Newer biodegradable seeding agents are in development, potentially offering a greener alternative. As we look to the future, artificial intelligence is set to play a major role. Machine learning algorithms are getting better at predicting optimal seeding conditions and quantifying results. This could lead to more targeted, efficient operations and help resolve some of the lingering scientific debates about efficacy. But even with AI assistance, cloud seeding remains as much art as science. A program operator in Colorado puts it this way: "We seed only during narrow windows when clouds are physically primed. It's about working with nature, not forcing it." That humility in the face of nature's complexity is a recurring theme among experts. We've come a long way in understanding cloud physics, but the atmosphere remains a chaotic system full of surprises. So, can humans make it rain? The answer is a qualified yes. Under the right conditions, with the right tech, we can nudge the odds in our favor. But we're still far from the realm of weather control seen in science fiction. As water scarcity becomes an increasingly pressing global issue, cloud seeding will likely remain a tempting option for many regions. But it's crucial to approach it with realistic expectations and a thorough understanding of both its potential and its limitations. The future of weather modification may lie not in grand schemes to remake the climate, but in subtle, localized interventions that work in harmony with natural processes. As we continue to push the boundaries of atmospheric science, one thing is clear: respect for the intricate dance of wind, water, and temperature that creates our weather will always be key. In the end, our ability to make it rain comes down to this: we can set the stage, but nature still conducts the symphony. And perhaps that's exactly as it should be.